In this final tutorial, we will add collision avoidance for our AI, as well as add the ability to overtake. So without further ado, let's get into the video. Okay, so the first thing we're going to do is implement the double lane system, because before we can implement the overtaking and collision avoidance, we need the AI car to be able to use more of the track. So we're going to implement the double lane system first. Now, where do we implement this double lane system code? Well, where we should implement it is where we get the location for the AI to drive, and that is currently in the path blueprint. So let's go ahead and open up the path blueprint. To do that, we're going to open up our content browser, and if you're on the content folder, you want to go to the AI folder, and then we want to open up the BP_AI path blueprint over here. And once it's open, you want to go to the get closest location to AI path function. And once you're here, you want to go to this right side where we do the get location at distance along spline. So how do we allow the AI car to drive in this two-lane system? How do we offset where the AI car drives to, well, make them drive at two separate sides of the road? Now, what we'll do is we'll use a get right vector. So the idea is that we want to add a right vector to this return value, and then we multiply that right vector with a value based on if we're on the left side or the right side of the road. So to do that, let's go ahead and do that. We're going to drag off the select float, and then we're going to type in get right vector, and we're going to use the get right vector at distance along spline. We're going to move this up a bit, and then the coordinate space you want to set to world because we want to use world location. And what we want to do is we want to drag off this return value and do a plus or an add operator. And we want to drag this return value into this add operator. Actually, no, we don't want to do this. What we want to do is we want to manipulate this value. And to do that, we're going to drag off this return value and do a multiply. So we're going to use the multiply operator. And now we'll go ahead and connect this into the plus, and then connect this into the location to steer to. So what multiplication should we do here? What should we calculate here for this to work? Well, what we need is we need to know what side of the road the AI car is driving on. Now, there's multiple ways to store that, but the best way I found is to store that information in the AI car itself, and then when you're calling this function, to feed it into the path. So what we need to do is we need to add an input to this get closest location to AI path, and then plug that into here. So to do that, we're going to open up our content browser, and then we're going to open up the BPI_is AI path. We're going to click on the get closest location to AI path, and then we're going to go ahead and add a new input. We're going to set the type from Boolean to integer. We're going to call this side of road. And let me just go ahead and compile and save, and we can close that down. We don't need that anymore. And how is this going to work? Well, first, let's right click and type in get side of road. We're going to use this. And how this is going to work is if the side of road is 0, that means we're on the left side of the road. And if the side of road is on the right side, that means, it's for example 1, that means we're on the right side. So how do we use this numbers? So how do we convert the 0 and 1 into a usable multiplication or usable calculation for this? Well, what we can do is we can right click and type in select float. And what you should see is there's an A input and a B input and then a Boolean input. But as you can see, there's no integer input. So how is this going to work? Well, the idea is that the side of road is going to feed into this Boolean value. Now, if you didn't know, integers can be converted into Booleans. The idea is that if an integer is 0, that means false, and if an integer is 1, that means true. So if we go ahead and plug the side of road into the pick A, then we just move this a bit. Then if the side of road is 1, aka we're on the right side, A is picked. If we're on the left side and this is 0, B is picked. Let's go ahead and plug this return value into that multiplication. And then finally, these values, what should we set them to? Well, this is based on your current track. So let me show you how to calculate that values for your current track. So to do that, you want to go to your vehicle example map. And here at this path, so we want to find with the path start, want to select it. And then in the bottom right or under the details panel, you want to click on the spline component itself. Then you want to scroll down all the way until you find this value called scale visualization. Just want to tick that on. And now you should see this weird circle fin that doesn't make any sense. But the idea is that these two lines at the side is where the AI car intends to drive in this two-lane system. So if I set this value to, for example, 200, that means that the left side of the road, the left lane is here and the right lane is here. Now, of course, this is way too close for these two sides to be driving on. So what we can do is we can set this value to 500. And now this looks way better. So this is all based on your track. So you just want to adjust this based on what track you have. But 500 seems to work for this track. So I'm going to turn off scale visualization, go back to my BP underscore AI path. And if we are on side of road, 1, so that means we're on the right side, we pick A, and that means that we should do 500 in the offset. But if we're on side of road 0, that means we pick B, that means we should be minus 500. The reason for that is because this is right vector, so minus is left and positive is right with this. But yeah, this is set up. If you want, you can get the value of this from your level blueprint, and that would be the best way to handle this. But to save time for this tutorial, I'm not gonna develop that system, but that's the best way to handle that if you're planning to put this in your game. Just get these values from the level blueprint itself. Now with that out of the way, let's go ahead and clean this up. We're just going to move this return node a bit to the right, and then we're going to select all of this over here, move it to the right, select all of this again, press C to comment. We're going to change this comment block to add offset based on side of road, and that should be a good name. Let's move this up a bit. Something like that should be good. This line seems straight, and yeah, this is cleaned up and ready to go. Now we can go ahead and compile and save. And what we should see is if I go to the vehicle example map and hit play, we should see the AI car drive on the left side of the road. And the reason for this all is because by default, this function is 0. And we need to, of course, set that in the AI car. But that means it is working. If your car is driving on the right side of the road, you should make sure that these values aren't swapped around, because if your car is driving on the right side on that test, just swap these values around, and then it should be fully working. Now with that out of the way, let's actually, allow our car to drive on more sides of the road, because currently it can only drive on the left side, thanks to us not calculating the side of road. So to do that, we're going to open up our AI controller. So we're going to open up our content browser and open up the AIC underscore vehicle AI. And now what we need to do is we need to add a variable for AI car to say what side of the road it is on. So in the bottom left under variables, we're going to add a new variable. This is going to be called side of road. And we're going to change this from Boolean to integer, and that is good enough. We can compile and save. Now let's go ahead and set the side of road to 1, just to test. Let's compile, save, hit play, and let's see. Okay, our car drives on the left side of the road. The reason for that is even though we set the side of road to 1, we didn't send it for the function, because if I open up the calculate steering function, you can see the get closest location to AI path. The side of road is not connected to our variable. So in every function that uses that function to find the location to drive to, we need to go ahead and plug in our side of road. So let's go ahead and do that. We're going to go to calculate steering first, drag in the side of road here, move it down a bit, move both of these up a bit, and just move that one down. That's set up. We can compile, save, go back to the event graph, set steering, No, we don't want to do that. We want to open up calculate top speed. Here we use side of road. So we're going to drag in our side of road variable, move that down, move that up a bit, move that down, and we can compile, save, go back to the event graph, move a bit to the right, and let's open up calculate throttle / brake. And as you can see, we do not use that function. And I don't think we use that function anywhere else. So let's go ahead and compile and save. And first, make sure your side of road is set to 1. And if we hit play now, our car should be driving on the right side of the road. And as you can see, it works. So that means our code is fully working and ready to go. Now finally, let's go ahead and do the final thing for the 2-lane road. Let's drag this one a bit closer to the start, so over here, and let's hold Alt on our keyboard and drag away from this car to create a duplicate. And we're going to move that a bit more center. And let's move our player spawn a bit closer to both of these so we can see them. And if we hit play, you can see both of the cars are driving on the right side, and they're probably going to crash into each other. As you can see there, that's not good. So how do we get these AI cars to automatically drive on the side that they start? Now, let's go back to the AIC. And the general idea behind this is that we want to calculate on the begin play what side of the road the AI car is closer to. Now, if you were to create this for your own AI, for a game or something, what I would recommend is in the code where you do the grid system, you can, of course, as you are spawning in cars, designate a side of road. But if you don't have a grid system or just want to get something up and running quickly, I'm going to show you a bit of code, which isn't expensive, but it is definitely overkill for this. So let's go ahead and take everything in begin play and move it up a bit. Then we're going to, after this AI path, do a new function. So in the bottom left under my blueprint, let's go ahead and add a new function. We're going to call this function calculate starting side of road, and that should be good enough. It doesn't have any inputs, but let's go ahead and add a new output. It's going to be, of course, type of integer, and then side of road. So how is this function going to work? Now first, let's just move this return node a bit heavily to the side because we're going to need a bit of space. But the general idea is that we want to get the location of the AI car, check how close it is to the left side of the road, check how close it is to the right side of the road, and which one it is closer to, we'll pick that as our starting side of road. So how are we going to implement that code? Well, to do that, we're going to first right click and actually, let's go to the bottom left under variables and drag in our controlled vehicle. We're going to get our controlled vehicle. Then we're going to drag off of this and do get axle location. And this node we're going to use. So this is the location of our AI car. And what we can do is we can go to the bottom left and drag in our AI path, get that, drag off of that, and do the get closest location to AI path. I'm going to use message. I'm going to plug that execution pin over here. And then I'm going to plug in the get actor location into the AI location. Additional distance should be set to 0. And then this location to steer to, what we're going to do is we're going to find the distance between these two. And how do we do that? Well, we drag off the location to steer to and type in distance, and we're going to use distance vector. We're going to plug in the get actor location into v2, so vector 2. We're going to drag off of this return value and promote it to a local variable. And this local variable is going to be called left side distance. Now, it isn't a requirement to save this to a local variable. It's just going to make the code a bit cleaner. Now, with that out of the way, let's drag in the execution pin over here. And let's select all of this code over here, except this left side distance, and press Ctrl D on our keyboard to duplicate. Wait, let me just select everything again. Ctrl D to duplicate. I'm going to move this to the right side and then connect the set left side distance into that. And then instead of side of road being 0, we set to 1 to be the right side of the road. And then we drag off this distance vector's return value, road to local variable and call this right side distance. And we're going to plug the execution pin in. And then finally, we want to find out which side the AI car is closer to, so we can output the side of road. So to do that, we're going to drag in the left side distance, get it. We're going to drag in the right side distance variable, get that. And what we can do is if the we're going to drag off the left side distance and do a greater node. We're going to drag the right side distance into the bottom one. And if the left side distance is bigger than the right side distance, that means we are closer to the right side of the road. And now, just like in the AI path where we did this Boolean conversion, we can secretly do it here. And so if the distance on the left side is further away than the right side, that means we are on the right side of the road, or aka 1. So this is going to output 1 if we convert it. So that's going to be correct. So let's drag that into the side of road, drag in the execution pin over here. And then let's go ahead and select everything here. Press C to comment. We're going to call this get the side of road based on distance from each side. Let's go ahead and compile and save. And then we'll go to the event graph, go to the bottom left and drag or calculate starting side of road in, connect the set AI path into that. And then the side of road, we're going to go to the bottom left under variables, drag in the side of road, set side of road, and connect the side of road here. And if we compile, save, and hit play, you should see both AI cars drive on the side they should be driving. And yeah, that's good. So let's go ahead and increase the car count. So we're going to click on this one here, hold Alt and drag in one in the front, hold Alt again and drag one to the left. And let's hit play and let's see if it works. As you can see, they all are driving on the side they should be, but you can also see that they're eerily close to each other and so can possibly crash into each other. And the reason for that is because they don't have any form of collision avoidance or anything of that sort to actually avoid each other. So now in the next part of this tutorial, which is happening now, by the way, there's no next part of this, but in this next part of the tutorial, we're going to implement collision avoidance. Also, we're going to implement overtaking code based on the collision avoidance and all that. So let's go ahead and start with that. Now, the general idea for this is we're going to be using triggers. So we're going to add boxes around the AI cars, and based on what cars in the AI box, it will react differently. Now, there's a lot of ways you could do this. You can do this with array cars. You can also use the spline as a way to get information. But while those systems can work better than a box system, and I kind of do prefer them, they can get very complex very quickly. And it's just going to be a very, very, very long tutorial if we were going to use those. So we're just going to use boxes for that. So let's go ahead and add collision boxes to our AI car. So we're going to open up our content browser, and we're going to go to our content folder, vehicle template, blueprints. We're going to go to the vehicle advanced pawn, and then we're going to go to the viewport. I'm going to zoom out a bit. And let's go ahead and add boxes to our AI car. So we're going to go ahead, add a new component. This is going to be box collision. We're going to call this front box. We're going to move it into the front. We're going to go ahead and resize it. So I'm going to press R on my keyboard to scale. I'm going to scale this up. Let's just put it in front of the car still. Scale it up a bit, move it up a bit, scaled a bit wider. And now any car that is in this box, the AI is going to detect. And now based on that information, we can do stuff. Now that is good for collision avoidance, because what we can do now is we can know, okay, there's a car in front. Maybe I should slow down if I'm really close to him. But this isn't good for overtaking because, well, we have no information of the cars next to us. So what we're going to do is we're going to go ahead and add boxes for each side of the car to determine overtaking for each side. So we're going to go ahead and add under components a new box collision. So box collision, going to add a new one. This one's going to be called left side box. And of course, we're going to move it to the left side of the car. Let's scale it up. And this one you should scale pretty widely, because based on how wide your track is, you want to get as much of the right side as you can. But it's also very important to note that if you make this too wide and your track is very close to each other, then maybe the car will detect a person on another turn as in its way, and then it's going to be quite funky. So try to make this as big as possible, but if it causes problems, just scale it down a bit. Anyway, I'm going to make it this big. I'm going to resize it over here. And the reason for resizing it this way, or as big as it is now, the reason for this is that if a car is, building up speed and we try to swap into the lane, then the problem is that we're going to maybe swap into the lane too slowly, and this car that is coming along here is going to crash. So we want to make this car make sure that there isn't a car approaching at a rapid speed. Now, you can scale this box down based on how aggressive you want the AI to overtake, but for now, I just don't want a too aggressive overtake, and so I'm going to set this value to this. I'm going to scale it up, and then finally, we're going to add a box just like this, but for the right side. So we're going to right-click on the left side box. We're going to duplicate. We're going to call this right side box. Now that we have that, let's go ahead and move that to the right side, just about the same position. That should be good enough. Let's go ahead and drag this onto the mesh so that they aren't over each other. The front box, I think, should be above. Oh, well, I can't really set the sorting of that, so this is good enough. But let's go ahead and compile and save. Let's see if it works. So as you can see, it kind of isn't fully touching this car, so it's not really going to work well. So let's go ahead and just make the both side boxes just a bit larger. So something like 14, move them up a bit. Select this one, make it something like 14, move it a bit to the left. And let's compile and save, and let's see if it works now. As you can see, it now sees more of that car, so it's going to work now. Maybe I think I'm going to go ahead and improve this front box, because it is really small. So something like this should be good enough. Just make sure that it's a bit in front of the car, because you can have some very wacky behavior if it is touching the car, so just move it a bit in front of the car. But yeah, this should be good enough, so let's go ahead, compile and save. And if we go to our vehicle example map, as you can see, the boxes are touching the other cars in the other lane, so this is going to work perfectly for this. Now finally, at least for this, is that if we go to the vehicle advanced pawn, then we actually have a problem, right? So all of these boxes actually count as part of the vehicle. So if we go to the vehicle example map, and for example, look at this box over here, then this box is going to count as a part of this car. And so this car is going to detect that there is someone in front of him and someone to the left of him, and thus be very slow, even though, well, there isn't any car in front of him. So we need some way to make these boxes not register as parts of the car. And for that, we're going to set custom collision information for these. So if you click on these boxes, you want to go under the details panel, you want to go to search and type in collision. And then you can see here's a few collision presets. We're going to change the collision presets from overlap all dynamic to custom. And the query only should be on, so no physics collision. Object type world dynamic is correct. We're going to ignore all the collision responses except the vehicle. The vehicle we are going to overlap. And so you want to set that for each one of these boxes. So custom, ignore all, set vehicle to overlap and make sure that these settings are correct. Click on this box over here. Same thing, custom, query only, all dynamic, ignore everything except vehicle. And if you compile and save, now these won't count as parts of the vehicle, and so it won't cause any buggy behavior. So if your car is randomly just slowing down for no reason, just make sure that these collision presets are correct. Now with all that out of the way, we can go ahead and actually create the collision avoidance and overtaking system. So to do that, we need some way to feed these boxes to our AI car, to our AI controller. And for that, we're going to use a blueprint interface and feed it that way. So we're going to open up our content browser, go back to the content folder, go to the AI folder, and under BPI, or we're going to open up BPI underscore is vehicle. We're going to go to the top right and for my blueprint, add a new function. This function is going to be called get collision boxes. That should be good enough. We're going to add 3 outputs, output, and then all of these are going to be changed from Boolean to box collision. So we're going to type in box collision. So we want to set all of these to box collision. I'm actually going to delete those, add those because now everything's box collision. Then the first one is going to be front box. The next one is going to be left side box. The third one's going to be right side box. Perfect, we can go ahead and compile and save. And we should be done with this for now. Let's go ahead and implement that function into this AI car. So we're going to go to interfaces over here, and we're going to open up the get collision boxes function. And then now we feed the collision boxes in here. To do that, we're going to go to the top left on the components, drag in the front box, connect that to the front box, drag in the left side box, plug that into the left side, drag in the right side box, drag that into the right side box. Let's go ahead and move this over here, move this over here, move this over here, compile and save. And yeah, that's it for now here. And we should be done for the vehicle advanced spawn. But so every car you add, just make sure that when they are based on this vehicle advanced spawn, that you adjust the boxes for each car accordingly so that you know they aren't clipping or anything. That's just a general good rule of thumb. But yeah, we're done for that for now. Let's go ahead and actually implement the collision avoidance and the overtake code. Now to do that, we're going to create a function. So we're going to go to the bottom left under functions. We're going to create a new function, and this function is going to be called check for overtakes. So this function will exclusively check for overtakes or possible crashes and stuff like that, and then react accordingly. And now to, of course, do anything here, we need those boxes to get information from them. So in the bottom left, we're going to drag in the controlled vehicle, get that, and drag off of that and get collision boxes message. And we're going to plug in the execution pin over here. And that's it there. Okay, and now it is very important to note that thanks to the way we set up our collision, we don't have to cycle through everything here to make sure that they are vehicles or anything, because this is guaranteed to overlap vehicles, and thus will only give us information about vehicles. But we are going to have to adjust the front box. Actually, no, we don't have to worry about that. I was just overthinking this a bit too much. Anyway, what we can do is we can drag off of this front box and get collision. Let's go, get overlapping actors is the function you want. And so this will check what vehicles and stuff are in front of our car. Now, of course, this can return nothing. So what we're going to do is we're going to drag off the overlapping actors, do a greater than node, and actually, I'm just going to drag off the overlapping actors and type in length and plug that into this greater. And so the idea is that if there is if this value, if this overlapping actor's length is bigger than 0, that means there is a car in front of us, so we need to execute some code. So let's drag off of this and do a branch node. We're going to go ahead and plug this execution pen over here, and let's go ahead and do some code. Now, so for now, what I'm going to do is I'm going to save variables based on this information, because I want to see everything that's around the car before deciding what I want to do. So we're going to drag off of this value and promote it to a local variable. What we're going to call this is car in front. Actually, let's call this vehicle in front, question mark. And so if this is true, that means there is a vehicle in front. So let's just plug that into true. And also what we're going to do is we're going to get this overlapping actor and save its actor as a variable. So what we're going to do is we're going to drag off this overlapping actors, get a copy. This is going to be set to 0. And then we're going to drag off of this, promote to a local variable, and call this car or vehicle in front. So then we have a reference to the actor. And this way that later, if we want, we can check the speed of the car in front of us. And if there is no overtake opportunity, then let's slow down our car to fit the car in front speed. So this is just to get variables from the car later on in cases where we can't overtake him or do anything to be speedier. So let's just drag this set node's execution pen into that set node. Now, this is all the front code sorted. Let's go ahead and do the side code. So I'm going to select everything over here, move it a bit to the right. And I think let's do a sequence node so it does checks. So we're going to drag off of this. Actually, we're going to hold S on our keyboard, left click to create a sequence node. We're going to drag that execution pen over here. And the first thing in the sequence is we check if we have a vehicle in front. Then we'll go to see if we have a vehicle at the side. But before that, let's drag off this then one. We do a branch node. And then we're going to check first. Let's go get our vehicle in front variable, get that, drag off of that. And we just want to see if this is true. So if vehicle is in front, so we'll just drag that in. If there's a vehicle in front, we can check if there's a car in the side. If there isn't, there is no point to this because there isn't a car in front of us, so we don't have to worry about cars on the side because that means we can just speed up, right? So it's an unnecessary check that we are avoiding by checking if there's a car in front. Now, if there isn't a vehicle in front, we can check if there's an overtake opportunity. So now we can go ahead and copy this code over here and connect that to the true. But it's important to note that we don't really have to worry about getting the actor because we don't care about the speed of the car next to us. We only care about the speed of the car in front of us for brake control and all of that. But we also have a problem with this vehicle code where we check the car on the side because, of course, we don't know what side to check. So we need to check different sides based on, of course, what side we are currently on. So let's select all of this code over here, drag it a bit to the side. Let's drag in our side of road variable, get that. And then what we're going to do, so we're going to drag off of that and do another branch node. So I'm just going to right click, type in branch. Actually, if you hold B on your keyboard and left click, that also creates that. I just forgot for a second. Drag in the side of road here. So we're going to just move that branch node up here. And so if side of road is 1, aka we're on the right side, that means we should then drag this true node in here. And then the check should be right side box. If this is false, we can select off this code over here, copy paste, and we can drag in the false over here. And this value, we're going to just make this left box. And these vehicle in front booleans, we just want to go ahead and delete those. And we want to, of course, create variables specifically for left and right. So we're going to go ahead and take this vehicle in front, right click, duplicate, and call this vehicle in left side. And then we're going to duplicate that, right click duplicate, and make that vehicle in right side. So now we know if a vehicle is on the left and right side, so we just need to apply that. Right side, we're going to drag in here, set the vehicle right side, true, plug that value in here, and then vehicle on left side, drag that, set, true, plug the boolean over here. And yeah, now we know if there is a car in the left and right side, and now we can thus do code based on that. So finally, we're going to go ahead and add a new pen to the sequence, and now we're going to do code here based on... so this is the place where we're going to do the code where we decide what to do. Now to do this, we're going to drag off this den2 actually. First, let's move all this code to the side because this might get a bit messy. Let's drag off this den2, and we're going to start off with a branch node. And what we want to do is we want to check if a vehicle is in front, or boolean, or a vehicle is in left side. Actually, no. We want to check if a vehicle is in left side or right side. So a vehicle is in left side or right side. So, and a vehicle is in front. So we're going to drag off of that, do an add, not the add. We're going to drag off of that, type in and use an and boolean. And I'm going way too fast, so let me actually explain what's going on here. So what we want to do is we want to check if a vehicle is in front and if there's a vehicle in the left side. So if there isn't a vehicle in front of us, then this code won't matter. If there isn't a vehicle on the left side, it won't matter. So why are we doing these checks? So the idea is that if a vehicle is in front of us and there's a vehicle on the left side, and that is true, then we want to run code to slow down our car to the speed of the car in front of us. If this is false and there isn't a vehicle in front of us, or there isn't a vehicle on the left side, then we're going to overtake practically, because now we know we can. Now with that out of the way, let's go ahead and write this code. So if it is true there's a vehicle in front and there's a vehicle on the left side, then what we're going to do is we're going to override the speed of our car to match the car in front of us. So while you could technically use these boxes as a guide for it, what I personally do is I check the distance of our current car and check the distance of the AI car, compare them, and then use code specifically to that distance. So to do that, we're going to go to the bottom left, drag in our controlled vehicle, get, drag off of that, and type in get actor location. And then we want to get the location of the car in front of us. So we're going to drag in the vehicle in front actor variable, drag off of that, and do get actor location. And then we're going to find the distance vector between these two. And then we want to check if this value is greater. So you want to use the greater now. If this value is, for example, greater than 700, then we should match our car speed. Actually, no, this should be less than. So drag off this return value, do a less than, and make sure if this value is 700. So if there's a car right next to us, so we can't overtake the car in front, and there's a car in front of us, then based on how far we are from the car, in this case, if we are closer than 700 units, we will limit our car speed to the car in front of us. So that means we will brake our car so that we don't go too fast and crash into the car in front of us, because we have no overtake opportunity. So let's go ahead and drag off of this, do a branch node, not a branch node. I don't know why I keep making that same mistake. Anyway, let's drag this true branch into that, and then let's go ahead and run some code here. So for this, all what we're going to do is we're going to have a variable called override top speed, and that's going to be a boolean. And the idea is that in our vehicle AI, the code where we calculate top speed will have an override. So if there isn't a car in front of us, we'll follow our get current speed function. If there is a car in front of us and there's a car next to us and we need to slow down, then we're going to override the top speed to the car in front of us. So let's go to the bottom left under my blueprint, add a variable. This variable is going to be called override top speed question mark. going to change this from integer to Boolean. We're going to add a new function or new variable. This one's going to be called override top speed. And this one is going to be float, because this is the top speed we want to override to. So we're going to drag in this override top speed, set it, drag that, set this to true, because we are very close to the car in front of us, and thus we want to slow down to its speed. And then we want to drag in the override top speed, set that. And now we need to get the speed of the car in front of us. So we're going to go ahead, drag in the, go to local variables, drag in the vehicle in front local variable, drag off of that, and get current speed message. We'll go ahead and connect that up here with the execution pin, plug in the current speed over here. And now if a car is in front of us and we can't overtake, we'll slow down to the car in front of us speed so that we don't crash into them. So now we have collision avoidance for cars in front of us, so we can reduce the general crashing of our AI car. Now we can go ahead and do some overtaking code. So where should we do this? Where should be a good place to do this? Okay, and I actually needed to go ahead and open my other project where I actually fully completed this just to check. But what we want to do is off this false value, we want to drag out and do a branch node. I'm going to type in branch. And the idea is that we want to check if there is a car in front. So we're going to drag in our vehicle in front, plug that into the condition. And so if there is a car in front and on the left side or the right side based on whatever, then we should limit our car's speed to the car in front. But if this is false, and if we have a vehicle in front of us, and this means there isn't a car to the left side of us, because, well, as you can see, this check failed. So that means that we are ready to go. And if this value is true, that means we can overtake, and we can swap lanes to do that. If this value is false, then we don't have to overtake because there's not a car in front of us or a car right next to us. Quite a confusing flow of nodes, I understand, but I'm trying my best to explain this. But it can get quite complex, as you can see. But now with that out of the way, let's reiterate. True, that means there is a car in front of us, but there's not a car next to us, so we can overtake. False, there's not anything in front of us or next to us, so it doesn't matter, we can just continue. Anyway, now with that out of the way, what we're going to do is we're going to drag off true. Actually, we're going to go to the bottom left, drag in our side of road, get side of road, and we're going to right click and do a select node, a select integer, so we want to use a select int. And so we're going to plug in the side of road into A. So if side of road is 1, that means that we are on the right side of the road, it will pick A, and thus we need to set the value to 0. If side of road is on 0, that means false, that means it's going to pick a B, and so we need to set the value to 1. Again, bit confusing, but once you get over this confusing boolean to integer thing, it gets quite understandable. But now with that out of the way, we can go ahead and drag in our side of road, set side of road, drag in the return value, and just plug in the true. And then finally, this override top speed, we need to change this variable if there isn't cars in front of us. So let's go ahead and go back to our first sequence. And then here where we do this check for the branch, what we need to do is on false, we need to go ahead and drag in the override top speed and set it. In this false, we want to not override speed because there's not a car in front of us. If this is false, no car is in front of us, and we shouldn't have to override speed. Now, next to this, vehicle in front, if this is false, again, no need to override the top speed. So set override top speed. Actually, wait, this check is unnecessary because if vehicle in front is not there, this code will not run to begin with. So this branch is useless. You just directly connect this false over here. Sorry that I messed that one up, but yeah, we don't need that extra check. This does it for us automatically. But anyway, this one, override top speed should be false. Over in here, let's also override the top speed. Override top speed set here. This one should be false. This one should also be false. Override top speed. Anywhere where there is an open execution pin, you want to set override speed top speed to false. So as you can see everything here. And our code is a bit filthy right now. It's not really cleaned up, but let's go ahead and actually test our code. Let's go ahead, compile save, go to our event graph, and actually hook up this fin. So in the event tick, we're going to drag this out, drag in the check for overtakes, connect that up, and connect that up. And one more thing before I forget. This override top speed and override top speed boolean, this speed and this boolean, we need to actually implement that into our function. So let's go to the event graph. Let's go look for where we do the calculate top speed. Go to that, and then let's look for the code where this is going to work. Okay, so here we're going to move this calculate top speed. We're going to drag in the override top speed, do a branch node. And so if override top speed is true, let's just, go ahead and do that. If this is true, we just need to ignore this code overall and then output the override top speed. So we're going to right click and type in return, add a return node. Then we're going to move our override top speed into here, get override top speed, plug that in there, plug the true into there, plug the false into here. So if override top speed's false, we actually calculate the top speed. If it is true, we just output our new overridden top speed. Let's compile, save, and let's hit play. Let's see what happens. So you can see our AI cars actually drive. As you can see, around the turns, they start braking. What's going on here? Oh no, they're going wacky and there's something wrong with our code. So let me actually go ahead and check to see what is going on here. Okay, so as you can hear in the change of my voice, I've been here for a while and I found out it is a really stupid bug. So the first bug is that here, where we actually check the car's left side and right side, these should be swapped, because if side of road is 1, aka true, you don't want to check the right side, you want to check the left side because you are currently on the right side. So you just want to go ahead and swap these two around. So true should be here and false should be here. So let me just connect that up there, move this a bit closer. And then finally, here where I said that a branch was useless, clearly I misspoke because that was the most important part of this. So let's drag off of this, do that branch load again. And then finally, all we have to do is check if there's a vehicle in front. So let's go to local variables, drag in vehicle in front. So if there is a vehicle in front, let's swap out. If false, what we can do is we can again set the override top speed. So let's drag in the set override top speed, plug in the false, set override top speed to false. Also, we can set it here to false. It's also a good place to set it to false. Plug that into there, move this up, and this should produce better results. Actually, one thing as well, what you can do is here, this doesn't have to be a branch node. This we can just plug in directly here. And so if this is true, it will call this. And if it is false, it won't call them. So that is a cleanup we did just there. Other than that, another cleanup we can do here is just connect the false in here as well. That is another cleanup. Other than that, we should be ready to go. So let's go ahead, compile, save. Let's see if it worked. So if I press F8, you can see the cars drive. They're driving. Oh, that's good. Oh, he swapped. Oh no, they're doing it again. Okay, and I know why. This wasn't a cleanup. This was a screw up actually, because if this is false, it's also gonna run this, which is gonna run this anyway. So yeah, no, this needs to be separate. Tried to be sleek there with the code cleanup, but I might just ruined everything. Compile, save, and now this should work finally. Let's see if it works. hopefully. And as you can see, the car behind them brakes because the car in front of them is slowing down. What you should see is they do this around every corner. So now they avoid crashing into each other. Now here in front should be a prime opportunity for overtake. So this car should now try to go into the other lane to overtake. So let's see if he does it. And currently it doesn't seem like he is doing the overtake. So this seems to be a problem with the overtake code. And so I found out the reason why it wasn't really overtaking is because of our previous box sizes. So previously the boxes were too close to the AI car on the left and right side. So it would happen that the AI car would think there's a car at the side, but it's actually the car in front. So all you want to do is just give the right boxes and left boxes a bit more spacing to work with, and also widen the front of the car so that it detects better. Something like this setup should be good enough. And if we hit play now, press F8, you can see our AI car drives around, sees the car in front is braking heavily, and now it's just trying to follow its footsteps. You can see they speed up, brake again. So currently they're collision avoiding. There should be an overtake opportunity happening there, so it does that. This car notices this one swerved in front of him, so he's going to move into that lane. And so now this car has the advantage because it has the inner lane. So you can see it is going good there, but now it's going to, of course, have the disadvantage because of being outer lane. But overtake did happen there. It noticed there was a car in front of it, and thus wanted to overtake to fix that. And yeah, as you can see, we have overtake in collision avoidance. The car avoided crashing into each other because it was checking the car in front of its speed and was working around that. So yeah, we have working collision avoidance and working overtaking code. You can also see if I hit play, for example, now, go with my car. Let me just try to get in front of these people. Let's get in front of this row. You can see now he swerved out just to get out of my way, so they won't crash into me as well. So now they also have collision avoidance with me because I'm the same as the AI cars. So yeah, that's pretty good. Now it might have not been a speedy overtake, but some things you can do is something you can do that I think would work really well, and I've tested it previously. But something you can do is that when your car is overtaking, you can add an additional speed boost to the car temporarily. So let's, for example, say for 3 seconds our car has a 10 km/h boost so that it overtakes speedier. Something I've also done which works really well is going ahead and increasing the distance it looks ahead, because this also generates pretty good overtaking patterns. Because currently when it is overtaking, it overtakes way too steeply or way too aggressively to the side. So something you can do temporarily is increase the distance of its look ahead so that it would more overtake in a more straight line. But these are all things you can do to improve the AI, and I'm not really going to talk about them because that's really something I want you to experience on your own. But they aren't really hard to code. I just know you're going to have to use the event graph for it because stuff like delays and timers don't work in functions. Anyway, one thing we can do is, of course, clean up the check for overtakes function, but also we can not put this on tick, because something we can do is we can move this to the begin play, drag off the set side of road, and do a timer, type in timer, and we can use set timer not by function name. Actually, we can maybe do that. Set timer by function name, and then the function name, we're going to change that to check for overtakes. And you want to make sure it's precisely spelled like this one. So check for overtakes, it's precisely spelled like that. Time should be 0.1 and looping should be on. And what we did now is we actually did the overtake checks more slowly, so it's a bit more performant. So if your overtakes is a bit rough, you can decrease this value for better values, but making it more expensive. If you want, you can increase this to 1, and now it's going to check for overtakes every second. But 0.1 is a good like performance cut down. And now with that out of the way, let's go ahead and actually clean up our check for overtakes function. So we're going to select all of this over here. We're going to comment this and call this check in front for car, or not check in front for car, check for in front for vehicle. And then these, we're going to select all of these over here. Press C to comment, and this we're going to call check for vehicles left and right. So, okay. And then we'll move this a bit closer. Just move these nodes over here. And these, we're going to select all of these at the bottom, move them down. What we're going to select, these. We're going to press comment and call this slow down if there is a vehicle in front and we can't overtake. And this one will just comment and call overtake. We can move this down a bit. We can select this, move it around like this. Maybe move this a bit, move this a bit. Currently just cleaning up nodes overall. This is mostly what it's going to be now. This one we can move closer now. This one we can also move closer back to this. We can clean up this dramatically. So let's move these in here. Move these closer. I think we can also move these overall very closer. Something like this should be good enough. And yeah, this is cleaned up and looks way better overall. Maybe this one I'm going to move a bit to there. But yeah, this is generally clean up. Wait. Okay, yeah, this is clean enough and is descriptive enough to understand what is going on. And yeah, that's it for this tutorial and also this tutorial series. I gave a few pointers on how to improve the overtaking. Of course, using wider like turn distances and stuff like that, using delays and speed ups is a really good way. And I've tried to give as many pointers as I can to improve this AI, because while I would love to make it, you know, the ultimate AI, I've spent hours and hours improving at the AI, and for me to make the ideal AI that I wanted with all the racing lines and all that would have taken very, very long, and I just don't think I would have done it at the end of the day. It was just going to be way too much. So I think I'm going to cut off the tutorial series here for now. This is the finale currently. I might come back to this. I might make new episodes, might add a bit more. But like I said, I'm trying to give as many pointers for you to improve this code as you can, because if I don't come back to this, you have some ways to improve the code for yourself. But yeah, that's it for this tutorial series. Thank you guys for watching. If you like the content, please subscribe. Hit like if you liked the video, hit dislike if you didn't, and see you guys in the next tutorial. Good night, everybody.